Welcome to today's webinar, Integrating Amazon ElastiCache into Your Database Stack. Our presenter today is Dan Zemansky. Dan is the lead product manager for Amazon ElastiCache. He's a technology enthusiast with over 10 years of experience. Prior to Amazon Web Services, Dan held engineering roles at Elbit Systems Ltd., and he holds a Bachelor of Science in Electrical Engineering from the Technicon, Israel Institute of Technology, and an MBA from UNC Chapel Hill. Today with us, we also have Arash Asari, Systems Development Engineer, Kevin McGeehee, Senior Software Development Engineer, Alan Ferris, Software Dev Engineer, and Mike Labib, Solutions Architect. They will serve as our webinar moderators, and they will be engaging with you during the live webinar and answering your questions as they come in. Dan, welcome. The floor is now yours.
All right, hey guys. Thanks for joining our webinar. Integrating Amazon ElastiCache into your database stack. So my name is Dan Zemansky, and I lead product management on Amazon ElastiCache. As mentioned, we'll have 45 minutes, roughly 45 minutes for the presentation, and then we'll leave some time at the end, and we'll be happy to answer any questions you guys have. So this is the learning objectives that you guys saw when you signed up for this webinar. And we'll start with explaining what ElastiCache is and what is the key value, what are the things that it can do for you. We'll then go into how do you design, how do you set up an ElastiCache environment, how do you design for high availability and for persistence. We'll talk about some of the common use patterns, what you can do with ElastiCache, and then we'll conclude this with tuning metrics that you get in ElastiCache, as well as some common challenges that we see our customers face and how do you handle those. So before we talk about ElastiCache, just a few words about the evolution of modern applications. Right? With the proliferation of mobile applications and connected devices, we see that people interact differently with applications. So first, we're seeing more and more applications that require real-time performance, whether it's games, e-commerce, social apps, etc. There are both studies, but also many anecdotal pieces of evidence that we get from our customers that their users don't want to wait. It needs to be the app needs to be real-time, and the users are sensitive to its responsiveness. So if your application becomes slow or unresponsive at times, they might just simply leave and not come back. Obviously, we would want to avoid that. In addition, the user experience is becoming more contextual. Okay, so what I mean by contextual is no longer this one-size-fits-all application or website, but it's tailored content. So you log into an app and you see your own Facebook updates, likes, tweets, images, etc. What this means is the traditional approach to having application perform fast with putting a static content in a CDN, that is still great, but that's not enough anymore because you have all this contextual. You have this contextual content for every user. And another challenge that we see is the load is being spiky and unpredictable. And let's talk a little bit more about this. So the chart that you see shows a social media stream analysis of a hockey game, and that's a Stanley Cup Finals in 2012. And what you see here is when a major event happens in the game, the amount of activity that the social activity that you see varies significantly, and it's really significantly. So you see orders of magnitude. Now the biggest spikes in activity, which mean the biggest spikes in load on your application, on your database, they come exactly when your user is expected to perform the most, and that's when something interesting is happening. We're seeing such cases all the time, whether it's a spike as a result of a big sports event happening, or maybe a celebrity mentioned your application interview, etc., etc. And then all of a sudden you have a huge spike in access or in usage of your application. Now, if you're provisioned to that steady state in your database layer, when such a spike comes in, your application might become slow or even crash. And that's something that we definitely want to avoid. So now that we articulated the problem, the challenge, let's see what is ElastiCache and how it can help you deal with that. So ElastiCache is a managed database service within the umbrella of AWS Managed Services. And of what you see here are the main database services where you can store your data. So many of you might be familiar with the concept of AWS Managed Services. So we'll recap this very quickly. If you run your application on AWS instead of on premises, AWS offloads many tasks such as buying hardware, server maintenance, etc. But if you want to run a database, there's a lot more to be done. So this is what you can see on the left with the gray list. And so that's a long list of tasks that are undifferentiated for your customers, such as scaling your database, designing and maintaining availability, backups, patches, etc. Once you move to a managed database services, and that's what you see on the right, we take care of all those tasks for you so that you can focus on what matters to your customers, which is your application. So on a high level, ElastiCache is an ultra high performance, fully managed, in-memory key value store service. So ultra high performance, fully managed, in-memory key value store service, and we'll break down each of those as we go along through this presentation. It allows you to run the two most popular in-memory engines, Redis and Memcached, in an optimized, robust, and managed way. And throughout this presentation, as I said, we'll cover these main features of the service in more detail, and we'll also show you how to set those up. Now, in the interest of time, in this webinar, we will focus on Redis, and the examples that you see are from Redis, but many of the capabilities are also applicable, and you can use them the same way for Memcached as well. So this is a very colorful slide, and what it's here to illustrate is basically the main services on AWS where you can store your data on a scale. Now, on the right, you see the coldest data, so data that you need to be durable, you need it to be there, but you also don't access as often, and therefore the latency of getting it isn't as critical. The classic example of that is Amazon Glacier, which now is mainly used for archiving. You store your data there, and then you can get it out when you need it, but you don't need it right at this very second. On the other end of the spectrum is needing the data as fast as possible and at a high request rate, which is a perfect fit for an in-memory database. That's why, in terms of latency, ElastiCache, if you want fast access to your data, ElastiCache is the fastest service in AWS, and this is where you would want to store data that you need fast. Now, how fast? That's in sub-millisecond latency. So calls to ElastiCache, you will get those in most commands you get in less than 1 millisecond of latency. So what is it that ElastiCache can do for you? We have divided the benefits into 6 main categories. Now, of course, this is an overview, and we will go more into detail on the key features later in this webinar. But on a high level, let's go over those. So the first one is extreme performance. And we covered that in the previous slide, why ElastiCache is the service that you want to consider for your fastest data. But on our end, we also optimized and tuned ElastiCache from the binaries all the way down the stack to the OS and the customer dedicated nodes so that you get that fast performance. Second one is open source compatible. All these powerful capabilities of Memcached and Redis that you get, they're available with ElastiCache, and we're fully compatible with open source. So that means there is no lock-in concern for you to use in the service. It's easy to take an existing application code if you're running self-managed Memcached and Redis and move it into ElastiCache, and it's just as easy to move out. Basically, the application code will work as is, whether you're running it on self-managed or you run it on ElastiCache. Third is fully managed. So we covered that part. You no longer need to worry about things like hardware provisioning, software patching, setup configuration, monitoring, failure recovery, backups, etc. We continuously monitor your clusters, and then we take the necessary action to keep your environment up and running so that you can focus on the application. Fourth one is security. So security is always #1 priority in AWS, and in that sense, ElastiCache is no different. So both in terms of securing access to your data through things like Amazon Virtual Private Cloud, VPC, and IAM, and also monitoring your node and applying any security patches whenever it's necessary. The fifth one we'll go over more detail, and that is ElastiCache provides options for high availability and scalability, and we'll show you through this webinar how to set that up in the right way. And finally, cost effective. So when you compare running a self-managed EC2 instance, let's say of Redis, versus an ElastiCache for Redis, you're looking at, for a fairly large instance, you're looking at a price difference of ownership for between $20 and $40 a month. So this is, if you think about it, if you have an engineer that spends more than 30 minutes of their time a month tuning your Redis or Memcached, that's something that's cost effective. And the reason we can offer service in such a cost is because of the economies of scale we're able to leverage. One other thing that we'll see is if you're using ElastiCache, the internal data transfer cost between your primaries and replicas in Redis is also included in the price, which is not the case if you're running it on self-managed. So let's do a quick overview of the two engines we support, Memcached and Redis, and let's start with Memcached. Memcached has been the golden standard for caching use case since its creation in 2003. And what made Memcached really popular is it's both very fast, so it can get you answers in sub-millisecond latencies, and it's also very simple. So very simple API, mainly gets and sets of strings and objects. It's also easy to scale horizontally, and it's multi-threaded. The downsides of Memcached, and those that eventually helped Redis to take the crown in this area, are lack of availability and persistence options. So in Memcached, there's no way to set up any replication or high availability for your data. And as well as there is no support for more sophisticated commands or data types. And this brings up to Redis. So Redis it's as fast as Memcached, but it's more of a in-memory data structure server. So it's not a caching engine. And since its introduction in 2009, Redis has become the most popular in-memory key value store out there. So really the reason is it's been able to maintain the same or similar blazing fast speeds of sub-millisecond latencies while supporting advanced data structures such as lists and hashes and sets and sorted sets and hyperlog logs, etc., as well as providing around 200 commands that can provide some powerful capabilities. We'll explore some of those throughout this webinar. In addition, what made Redis popular is that it supports high availability and persistence, and we'll show you how ElastiCache helps you manage those. So why is it that ElastiCache decided to support these two engines? Well, what you see in this ranking done by dbengines.com among key value stores, Redis is the clear leader in popularity, followed by Memcached. But really we see it's not just these rankings, but also in terms of our customers, Redis is becoming the most popular choice for in-memory workloads. Now, DynamoDB is also a popular choice, as you see here. And DynamoDB supports both key value model and the document model. But it is used a bit differently. It's not an in-memory store. It's an SSD based. So the latencies that you get there are not sub-millisecond. So this is beyond the scope of this webinar. We'll focus today on ElastiCache with Redis and Memcached. So with that introduction on what ElastiCache can do can do for you, let's jump into how you can deploy a Redis environment on ElastiCache. And as I mentioned before, in this webinar, we'll focus on Redis. So the examples that you see are for ElastiCache for Redis. But many of the features and the console and the metrics are similar for Memcached as well. So this is a simplified app architecture. And you see the EC2 instances running your application as the orange squares. Behind the ELB, the Elastic Load Balancer layer on top. Then the application is connecting to ElastiCache for Redis. So you see that one node in availability zone A. And then you see that there is, in this diagram, there is another database, which is DynamoDB. Now, it doesn't have to be DynamoDB. It can be there or not, or any other database, but this is here for the sake of the example. But what you see, and that's important to understand, is there is no direct communication between the data stores. So between ElastiCache and DynamoDB, and it's your application that speaks to both. So when we explore later in this presentation, we'll explore the caching use case. We'll show you how to do that effectively and in a very simple way with just a few lines of code, how to manage what data you want to keep in one database layer versus another database layer. So let's talk about the multi-AZ with automatic failover that we support. So in the previous slide, we just had one Redis node in a single availability zone. Now, if you're going to production, once you're done with development and testing, we would want to use ElastiCache for Redis Multi-AZ capabilities for high availability, as well as manage snapshots for persistence. With Redis Multi-AZ, we attach one or more read replicas. It can be either in the same availability zone or in a different availability zone. So what you see here is we have two replicas, one on availability zone, the same availability zone as the primary, and then another one in a different availability zone. And then ElastiCache will automatically fail over to a read replica when a primary fails. Okay, now if you're using ElastiCache, the bandwidth of sharing the data across this replication group between the primary and the replicas is free of charge. It's included. So let's come back and now look at it in the context of our application. We're now running in production. So we have Redis node in availability zone A, that's the primary. And then we have the read replica in availability zone B. Now, the primary can be used both for reads and for writes. And the replicas is a read-only replica, so you can do reads from it. You cannot write to a read replica. Now, let's see what happens if your primary fails. So in the unlikely event of a primary node failure, what will happen is ElastiCache, first of all, ElastiCache detects this automatically, and we have robust detection algorithm that makes sure that if a node fails, we know that it fails, but we also maintain very low false alarms so that we are not too easy on this trigger of failed nodes. So that's something that's covered by ElastiCache as well. Once we recognize that the node has failed, we will select the most up-to-date replica and promote it to primary. So in this case, we only have one, but if we had more than one, we would also choose the right replica to promote. Then, after we did this, we'll update the primary DNS endpoint to point at the replica node. Now, this is an important part, so let me spend a few seconds talking about that. For a replication group, as you see here, that has one primary and one replica, ElastiCache will actually give you 3 endpoints. 2 of them are individual endpoints of the primary and the replica, as well as one persistent endpoint that always points at the primary. So once a failover has happened, we will propagate the DNS endpoint so that now this persistent endpoint points at the new primary. The reason it's important is because with that, your application doesn't need to change. You don't need to update the endpoints in your application, as long as your application is writing to that persistent endpoint. And this is exactly what you see in this slide. So once failover is complete, you see that the application is now those yellow lines. The application is now able to reconnect to the new primary, which is now in availability zone B. So we're not done yet. The last stage that ElastiCache does is it will replace the failed node in availability zone A with a new one and resync it to the replication group. So at the end of this process, you have one primary and one replica, which is fully functioning, just like before the failure occurred. And all of this process happened automatically without any need for your manual intervention. Now, one thing to notice is now your primary will be in a different availability zone. So you see that we started this with a primary in availability zone A. Now your primary is in availability zone B. ElastiCache does not automatically fail over again to return your primary to the original availability zone because we don't want to cause any unnecessary interruptions to your app. However, you can manually, if you want to have your primary, you have a reason to keep your primary in a specific availability zone, you can do that manually if you so choose. So let's just see how do you launch a replicated environment in ElastiCache with just a few clicks. So this is the create screen that you will see on the ElastiCache console. And you select the engine, you select the parameter group. If you're using production, we recommend you use replication and enable multi-AZ with automatic failover. You just type in your name, how many replicas you want, and you're done. So very simple. Once that is done, now in your dashboard on the console, what you see is 3 separate clusters that are linked together in a replication group. A replication group consists of a primary and its replicas. The first node is the primary, and the other 2 are replicas. Now, how do you get more information about this replication group? It's easy. You click on the link on the right that says My Game Dev. That's the name of the replication group. Or you can click on the replication groups tab on the left and then select this one. So that brings us to this screen where you see the details of your replication group. So this is the name of the replication group that you see here. At the middle of the screen, you see the primary endpoint, and that's the endpoint that will always point at the primary. So that's why you would want your writes to go to this one. You want to use this one. Then you see the roles of the 3 nodes you have. One is the primary, and then the others are read replicas. And finally, you see the screen on the right with options of promotion that are grayed out. The reason they're grayed out is we currently have the multi-AZ feature enabled. So right now, ElastiCache is managing all of this for you. But if you want to make manual changes, you can definitely do that. You click on modify that replication group, you disable that multi-AZ feature, then you can do whatever manual actions you want, and then you can enable that automatic failover again. And again, ElastiCache is back to monitoring and failing over when necessary. So we talked about the ElastiCache side of it. Right now, let's talk a little bit about how you do it in your application. So in your application, you would need to configure 2 separate sets of handles. Right? One is for writes and one is for reads. Now, then you would make a choice whether you read from your primary endpoint or you read from your replicas. So Redis supports asynchronous replication. What it means is the data in your replicas will be slightly delayed because the primary is sending it to the replica. Now, in practice, this delay is very small. We're talking tens of milliseconds max, usually less. But generally, we recommend that you write to the primary and do reads from the read replicas. An exception to that case is in some applications, the possibility of getting, even the small possibility of getting a very slightly stale read is unacceptable. And if that's your case, then what we would do is do both the reads and the writes from the primary, and just keep the replica for high availability for a failover. So the next thing is persistence. So let's talk about how you can set up your persistence. We support automatic snapshots, and that's another thing that ElastiCache manages on your behalf. So you can set up an automatic recurrent snapshot. You just give us the time when you want us to do it, and we'll take that automatically. You can also do a manual snapshot and initiate it at any time. So you can do that both from the APIs as well as the console. And what you see here is you click on Create Snapshot from your console. Now you see that it's the right cluster. You put the name that you want, and you're done. So once it's done, you will see it in the list of snapshots. So we snapshot our My Game dev, and you see that this snapshot is now available. Now you can click on it and click on Restore. It will get you to this screen. So it will pop up a dialog, which is basically a condensed launch wizard, which will launch a single node cluster. So you choose a name for your cluster. Don't forget to make sure that you're launching it in the right VPC and subnet so you're able to access it. And then finally click Launch the cluster. So now that we talked about some of the features that ElastiCache does to automate your deployment of Redis, let's explore some of the key patterns for using it. So the first use pattern that we'll explore is caching. Right? It's a very common use case for in-memory database. Now here your application servers are talking to a database, which in this case you see as RDS MySQL, but it can be any SQL or NoSQL database, whether managed or self-managed. In case the link between the database and the application gets congested, you can add a caching layer to offload reads from the database. Now your application servers will go to the cache layer first for reads, and they will get data in in-memory speed. Now this is something that we see both Memcached and Redis as popular solutions for the caching use pattern. Now caching allows your solution to be much more scalable and responsive because it gives you the low latency path to application, and two, that you can also independently scale your front-end cache to adjust to those spikes without having to grow the backend database, which is costlier and harder to scale. Now, I would like to emphasize that dealing with spiky loads is not only about kind of ensuring low latency, but being able to handle a high request rate, whether it's this one-off event in things like ed tech, or we see that a lot, or gaming use cases where you have big jumps, as well as in hotspots. And hotspots is specific popular keys that get accessed a lot more than others. So if you have an information that, let's say in a social application, if you have whether an item or a person that's connected to a lot of other people or items, then that key will get more access than many others. So just to recap on the previous slide, we kind of see some customers confused with that, so that's why I want to reemphasize it. The value, definitely there is a value in caching in cutting the read latency, but it's not the only value. So you see that as an increase in throughput, cutting the load on your database, and as a result of that, also the cost of scaling a database, which is a more costlier layer. So both in terms of cost, but also in terms of how it's harder to scale a database. Now it makes your performance predictable, and that's we covered that part. That this is how you prepare for those hotspots. That you have that cache layer. Then in case you have a big significant throughput coming in, Amazon ElastiCache and that in-memory system can handle much higher throughputs for each individual node than a disk-based database. So for typical web or mobile applications that are read-heavy, a common design pattern that we see for customers to integrate caching is called lazy caching. The way lazy caching works is every time your application does a read, it will go to the cache first, see if the data is there. If it's there, you got it at in-memory speed. If it's not there, the application will go to the database to get the value and then populate it in the cache for future read. So that next time you read, it will be there and you can get it in in-memory speed. Now, as you can see from the slide, is a very simple logic. So adding that caching layer to your application fundamentally is less than 10 lines of code. Another common pattern that we see is write-back caching. So instead of populating the cache every time there is a read request, like in lazy caching, here we populate the cache every time there is a write. So every time the application wants to write something to the database, we will write it both to the database and to the cache. And the trade-off here is this mitigates that initial cache miss. So in lazy caching, the first time you want to read the data from the cache, it will not be there, and then you put it in the cache. Here, you put it immediately when you write, so the first time when you would want to read it will be there. But the downside here is you would require larger cache because you might be putting data that is not frequently accessed or read. Right? The way lazy caching works is you will only be putting things in the cache that application actually wants to read. So there's a trade-off between having more data kind of saving you from that initial cache miss, but also requiring a bigger memory size for your cache. Now, this is, of course, a high-level overview, which is in the scope of this webinar. There are more things that you can do to tune your cache, whether it's choosing the right size, warming the cache, setting your TTL, your time to live, etc. But really the purpose here is to make sure that you guys are familiar with this concept because it's equally simple and powerful. So the caching use case was relevant for both Memcached and Redis, as both engines are popular for this. The next use case and the use cases that we'll see from now on are focused on Redis. So another popular use case that you see is leaderboards. Right? So think of a social application when you track your top contributors and top engaged users, or maybe a gaming app. That's something we see very popular and used in Redis when you have frequently changing rankings of your top players. So in your game, you might have thousands or 10,000s of players, but everybody would want to see the top 10 or the top 100. So these guys will be accessed a lot. Now, with new scores being generated all the time, right, you would want to keep that list sorted at all times, and you want it to be accessible fast because that high throughput, because a lot of people would want to see it. So this is where Redis can help. One of the data types it supports is sorted sets. And what you see in this example, in the first 4 lines, is we are populating that sorted set that we call leaderboards with their players and their scores. Now, when we do that, Redis automatically inserts the score in the right location to keep the sorted set sorted. And then you can do a couple of cool things. So you can either see, okay, give me all of my leaderboards, or give me part of my leaderboards, who are my top 10 or top 20 or top 100. And you do that with z riv range or z range commands that gives you a range of keys. Another thing that you can do is to ask for a specific player, tell me what the rank of that player is. Now, this thing both happens fast in Redis, but also the cool thing here is you do that sorting, that processing, as basically within Redis. So you don't need to run any background job. And that's definitely more efficient and simpler than having a giant MySQL database with some kind of a background ranking job running. So the third use pattern we'll cover today is chat and messaging. Now let's think of a chat room in a game or an application, or a real-time comment stream. And what you want is users to get messaging updates in real time. So for that, Redis supports the pub/sub capability. Now, if you look at the example below, you can have users subscribe to a certain channel. Then you publish a message to the channel. So you see here is publish that hello all to channel 114. And then everybody who is subscribed to this channel can immediately see it. And then if you don't want to see it anymore, you just unsubscribe from that channel. So Examples that we see our customers use it for, if you think of game chat rooms, now this is exactly what happens. You go into a certain chat room in your game with the people that you want to talk to, and then you see all the messages are going on there, and you can get out and go to a different chat room. Now, another example for this pattern, use case, is server intercommunication. If you have a system of multiple servers and you want them to communicate with each other, that is a very convenient way. And another one is for IoT systems. If you have one of those connected devices and you want to push an update from the server to all of your devices, that's something that's easy to do. You have your devices subscribe to a certain channel, and then you just send them messages. And they will get it in memory, both simple, you see this is 3 lines of code, as well as you get it in memory speed. So the fourth out of 5 use patterns that we'll cover today is ratings. So this you can use Redis. Another data types is called hashes. So Redis supports hashes, and it also supports atomic counters that you can increase and decrease in an atomic way. So think of modeling likes and dislikes for recommendation engine. So when a user likes an item or a product, you increment the counter, that total number of likes, and you can also store that item in the history of the user's ratings. Now, a map like that then shows you kind of the user's favorite products. From there, you can use Redis unions to combine those, and then based on that, you can get a recommendation or a prediction for a certain user what item he or she might like or want to buy. And there are some good open source algorithms that do such things. So an example of recommendable, that's a Ruby example you can see, and also algorithms like Slope 1 that you can read more about if you have that use case, but this is another thing which is very convenient with Redis. So another cool pattern that we see is rate limiting, which you can use for building or consuming an API. So I mentioned the atomic counters in previous case, and they come handy for this one as well. So imagine that you have an API that you don't want to overburden it. You want to limit the amount of access because you know how much your system can handle. So what you do is you use a Redis counter and you limit the number of accesses to that API for a certain time period. And then if the limit is exceeded, then you can reject that request. So again, very kind of both interesting, powerful, but also very simple way to achieve those use cases. So let's talk about performance and monitoring. ElastiCache is integrated with CloudWatch, and it provides you easy access to metrics that can help you monitor the performance of your cluster. So you'll see a few dozens of these metrics that you can easily see within your console or access through your APIs. Another thing you can do is set up CloudWatch alarms that will let you know when you're hitting a threshold on one or more of these metrics. So here are some important metrics to monitor. When monitoring CPU usage, and you always want to know, if you're not maxing out on your CPU, one thing to remember here is that Redis is single-threaded, so you need to multiply the reported CPU usage by the number of CPU cores to get that actual usage. So let's take an example. If you have a 4-core CPU and you see that it says 20% usage rate, right? What it means is 20% is an average, so that means that you have 1 core which is currently running at 80%. Okay? This is rarely a problem because it's very, very rare for us to see that the bottleneck on Redis workloads becomes the CPU, but it's a way for you to understand how you're reading that chart. Now, in addition to that, since it's an in-memory system, your swap usage should be 0 or close to 0, because otherwise you're using disk, and then obviously it's a much slower system. If you have high evictions, that means that you might be running out of memory, and new keys that you're putting in are evicting old keys because you ran out of memory, and then you might need a bigger node. So one of the things that ElastiCache supports is it allows you that simple API call or one click on the console to scale to a bigger node type. So you just click on modify cluster, you select a bigger node type, and what ElastiCache does, it scales you to that bigger node while preserving your data as well as maintaining your existing endpoint. So you do not need to, again, make any change in your application to that new endpoint. Now, finally, your current connection number should be stable if you're using persistent connections, and that's what we recommend. So if that number keeps fluctuating, or you see, we have another metric, it's called new connections, if that one is consistently going up, no, that's a sign that something might be misconfigured on your application level, and to look at that. So the last topic we will cover today before we go into Q&A is best practices to deal with some common issues that we see our customers facing. So the first one is the most common challenge we see in the caching use pattern that we covered earlier is the thundering herd. So thundering herd is basically happens in any situation where you have a ton of cache misses, and that results in your app server storming your database and overwhelming it. So common causes for that would be empty cache on startup. So if you start with a cache that's still cold, that doesn't have data in it, and you immediately have a lot of throughput that tries to get data. If you're doing some scaling nodes in Memcached, when you scale your nodes, that flushes some part of your cache because of the consistent hashing algorithm. Also, per node basis, you have actions that delete keys such as TTL, the time to live expirations, or if you're just running out of memory. Now, the solutions here are fairly simple, though you need to kind of understand how you set those up. So if we're talking about a cold cache, what you can do is make a script to populate your cache. So for example, if you know what keys will be the most popular ones, who are your most popular people in your app, or that the biggest scores or items or the most popular items to purchase in an e-commerce app, if you know that these will be popular, then you can pre-populate them in your cache before you turn on your application. And another is when you're scaling nodes, do it gradually and don't kind of just double your cluster size in one jump. Then regarding time to live, so TTL is a concept that you can put a time on the item that you put in memory that will be deleted after a certain amount of time when you believe that it's no longer needed or it's no longer fresh and you want to refresh it. Now, when you're writing a lot of items into your cache, what we recommend you do is set a TTL jitter, so a small random number, so that not all of your items or many of your items get deleted at exactly the same time. Because if that happens, right, then you might have that thundering herd problem. Now, as we saw on the last slide regarding evictions, if the number of evictions is going up, then you should consider growing your memory capacity allocated to caching. So it's important to understand how Redis backups and replication works, because the algorithm here is a little weird. So everything that I describe here is kind of relevant for both Redis snapshots, but also for Redis replication, because the way that the Redis works in synchronizing the primary and replica is using the same algorithm as the snapshot. It creates a full snapshot of the primary and then sends it to the read replica for initial sync. So that means that the same challenges remain. Now, Redis takes a point-in-time snapshot of the current memory state. What that means is while the backup is being written, new writes that are coming in are stored separately, and they require additional memory because you want to maintain, Redis maintains that point-in-time nature of that snapshot. Now, if this additional memory exceeds the total available memory on your node, then processing can become slow due to excessive use of swap, or in extreme cases, if it goes on and on, you might even make your Redis unresponsive. And of course, that's something that you want to mitigate. So let's talk about mitigations. The first thing is, a solution is you'd want to reduce the memory that you allocate to Redis, and we allow you to do that with a parameter that's called reserved memory. So reserved memory reserves some of the node that you have, some of the memory that you have on the node for such overhead as this save process of that snapshot. So let's take an example. If you estimate that the total size of your items to be 12 let's say gigabyte, one option is you can use an R3 large node that has 13.5 gigabytes, but you don't leave yourself a lot of room for snapshot creation. So if your application is write heavy and you anticipate a lot of writes coming in while you're doing that snapshot, then you can use something like an R3 extra large that has 28.4 gigabytes of memory, and then you have enough memory in case you need to do that. Snapshotting. So there is really a trade-off here between having more memory, so that that's increased cost, versus having less memory, but then taking that risk of running into these potential issues. And we recommend always having enough memory, or setting up the reserve memory in a way that will evict keys and not let your memory grow too much. So in terms of how the Redis reserve memory parameter works, so you set it up and you see there is memory that is reserved, and if there is more writes coming into Redis, they just get evicted. And then once you start doing that replication sync or snapshot, you see in your second line that it starts getting filled in that green. That green part is that overhead that's filled in a case where it's healthy. The third line, you see what happens if it gets overfilled and you didn't allocate enough reserve memory. So we recommend that you, depending on how write heavy your load is, you allocate up to 50% to this reserve memory. So let's recap what we talked about today in this webinar. In-memory is something that you should consider when you need fast sub-millisecond latencies and high throughput to access to your data. In that case, ElastiCache can help you do that by running Redis and Memcached, which is the most popular in-memory key value stores, in an optimized and fully managed way. If you're using Redis in production, we highly recommend that you use Multi-AZ with automatic failover. Keep your replicas in different availability zones from your primary, and also take daily snapshots. And the best practice here is we recommend you do those from the replica to minimize any load on the primary. Now, all these topics and many more are covered in our white paper that's called Performance at Scale with Amazon ElastiCache. And you can just Google ElastiCache white paper, and that's the first thing that will show up. So if you want to get started, that's easy. We have a free tier. If you're eligible for the AWS free tier, then you're eligible for the ElastiCache free tier, and you'll get 750 free hours of a micro cache node every month for up to a year. And without the free tier, you can begin with less than 2 cents per hour for a micronode. So this concludes the presentation part of the webinar. First, thank you very much for tuning in, and we will now open the stage for Q&A.
Okay, thanks a lot, Dan, for a great presentation, and to Arash, Kevin, Alan, and Mike for engaging with the audience throughout the presentation. On the left side of your screen, you'll see 3 polls. Please take a minute before you log off to click on the buttons next to the polls and give us your feedback. We have about 9 minutes left, so we're going to start answering your questions as they came in. We apologize in advance if we don't get to all of the questions. I'm going to hand it back over to Dan.
Sure. So thanks, guys, for submitting your questions. Let's go over as many here as we can. So the first question I see here is, if you're using MySQL as the database, which engine is better, Redis and Memcached? So that's a good question, and that depends on really your needs and application. So if you're saying that you have a main database, which is MySQL, I assume that you're referring to the caching use case. Now, if your application, you just need the cache for gets and sets, so you're not looking to use any more sophisticated data types of Redis, and your application can tolerate losing a node, temporarily losing that data, then Memcached can be a good solution. If on the other hand, if you want your cache to be highly available, so that even if your one of your nodes fail, right, and you don't have that thundering herd problem that we talked about in this webinar, kind of hammering your main database, then you can just use Redis. Set that high availability, use that multi-AZ, and that will be more fault tolerant. So the next question here is, how fast does the switch from the primary happens in case of a failover? So that's a good question. The failover process in ElastiCache has 3 stages. Has the detection phase, has basically the failover phase, and has the DNS propagation phase. Now, all together combined, you're looking at roughly 2 minutes of that whole process happening. Now, if you set your application the way that we recommend, when you do your writes from the primary and reads from the replicas, so that means that while that propagation takes place, right, there are no new writes that you can do, but you can definitely continue doing reads from the read replicas that are available. So the next question we have is, can ElastiCache work for a non-managed AWS service? So I believe that what you're asking is, if you have a database that works combined with ElastiCache in one application, can that database be non-managed? And the answer is absolutely yes. So we have many customers that do that. If you're running your own, whether it's a relational database or one of the non-relational, whether it's a Mongo or Cassandra or HBase, then you run that on your EC2 instances, and then you have ElastiCache. You need to make sure that you configure your VPC correctly so your application servers can access both, but that's definitely a common use case, and we see customers do that. And the next question is, how would my application recognize that the cache was swapping? Right, so that's another good question, and this is one of the metrics that we provide basically through CloudWatch. So you can see that in your ElastiCache console, and the metric is basically shows you swap usage. So if you see that swap usage starts going up, that means that you're swapping, and you need to see what's causing it. And one thing that might be causing it is the Redis replication, the snapshot that's being taken, and then you can use your reserve memory to make sure that you allocate enough memory so that it doesn't happen. So another question is, would ElastiCache make sense to improve the performance of an in-memory database like Mongo, or will you optimize Mongo to improve on performance? So the answer is yes. We definitely see customers using kind of ElastiCache to improve the performance of Mongo and of Cassandra. What we'll find is ElastiCache is very easy to use. right? An in-memory layer is much easier to scale. I know we get feedback from customers that scaling Mongo is something which is much harder to do. So that kind of multi-layer strategy, when you have your database and then you use ElastiCache in front of it as a cache and you scale it for fast access and for handling spikes, that's definitely very common. And it's common with MongoDB as well. So another question we have is about data integrity between cache and database, whether that is an application responsibility. So that's a good question. The answer here is yes. So if you have your application talking to your in-memory layer, your cache, and your database, right? What you need to, especially if you're using lazy caching, right? What might happen is you put some key in the cache, and then you made a write to your database, right? And then you have data which is not fully up to date. It's stale data in your cache. So there are several ways to mitigate that, right? Which most of them are beyond the scope of this webinar, but they do exist. So one of them is setting up the time to live, the TTL, so that every key that you have in your cache gets expired after a certain amount, so that it doesn't become too old. Right? You can use the write-through caching, so that every time you have a write, then you put it in the cache, so that you know that your data there is up to date. And there are also some algorithms on randomly selecting some part of your in-memory pool within ElastiCache and evicting it. And there is some theories on that show that if you do that by 5 or 10% of your cache, it also helps you maintain, it's called the liveness of your data. So there is a lot that you can do in that domain to keep your data fully up to date. So the next question we have is basically about persistence options for Redis. If there is support for append-only file NRDB snapshots, and also what is the frequency of those snapshots. So in terms of frequency, we allow you to set up automatic snapshots that you can set up daily, and you can also do a manual snapshot at any time. So we do have customers that if in cases where they need it very frequently, they can just have a command that runs every few hours that does it. However, if you need the data to be available, right, what we recommend is to use replication. So that's why the strategy we showed is to use primary and replication, and then have the snapshots for durability. ElastiCache, regarding AOF, append-only file, that's something that we recommend against using, because we found that there is a tax on performance that happens. And if you have your replication, so you have replicas with the same data and you have your snapshots, that's kind of the optimal strategy to both have your data available and also make sure that your system is performant, because it's an in-memory system, so performance is very important.
All right, thanks a lot, Dan, for a great presentation. And again, I'd like to thank our moderators for taking the time to answer the audience's questions as they come in. If you have any comments on previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please send us an email at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thank you to you guys, our audience, for taking the time to join us today, and enjoy the rest of your day.